So like I said, a lot of you already know, but we're gonna discuss it anyway because you need it. All right, it's a kind of foundation for this whole class. All right, what are the three components of an atom?
Electron, nucleus. No, neutron, my bad. An electron.
Proton, neutron, electron. Right.
Nucleus.
What's the charge of a proton?
Positive.
Positive. And it's technically a +1 charge. Okay? You'll understand why it's important in a minute. What's the charge of a neutron?
Neutral.
0. So 0. An electron? Negative. So we say a -1 charge. That's important because those cancel out, right? The proton and electron. What is the mass of a proton? Anybody? Okay. It has a mass of 1 AMU. You may know what AMU stands for? What?
Metric meter.
No.
A mini unit?
AMU units.
Atomic mass.
Atomic mass unit.
Unit.
Oh, really?
Yeah.
That's really deep.
Very good. Atomic mass unit. Okay. So, proton has a mass of 1 AMU. What about neutron?
Zero.
Pretty much the same.
It's the same. It's 1 AMU. And electron?
Isn't it like a 1,000
like-
of an AU?
Yeah.
It's
Very small.
we use 0 for its mass,
Oh, okay.
even though it has a slight mass. But it's so slight, it really doesn't matter. Okay. Scientists all over the world use the electron's mass as 0. Okay. Even though it has the actual mass. Same with proton and neutron being equal. They're really not. Okay. Neutron is slightly heavier, but it's so slight, it doesn't matter. Okay.
They're repeating forever. 1.
Yeah. Basically, the neutron is heavier than the proton by the same amount that the electron weighs.
Oh.
Okay, for the most part. So, what's the location? Or, I'm sorry, not to do this location first. Symbol. Do symbol first. What's the symbol for a proton?
Positive. Plus sign.
It's a P with a plus sign. Neutron is an N with a 0. An electron is E with a negative.
Okay.
Jarvis may have used the E with the negative in biology.
I don't remember.
She just used E.
She used a capital E for energy, didn't she?
Yeah, but the lowercase was for.
Electron.
Yeah.
So, location. Where do protons live?
Nucleus.
Nucleus. Neutrons?
Nucleus.
Electrons.
Electron
Green.
cloud.
Outside nucleus.
We don't know.
Oh.
That can't be determined. They could be anywhere.
They
Okay?
could even be in the nucleus.
They can even be in the nucleus.
Oh, I didn't know that.
Yes. I used to teach that the correct answer was outside the nucleus. But that is technically incorrect. When you do quantum calculations, there is a slight probability that you could find an electron in the nucleus.
It's whack.
How? Why?
Why? How? Because
That's all it is.
because they're moving so fast
Just cause?
that they can just fly right through there.
Oh, they just express their way through the net.
What she said. All right. Any questions about that? Okay. That chart will become very important. Okay. So if you're going back taking notes using the video, that's the one to get. Okay. Any questions about that? Y'all had a bunch of this 8th grade-ish, right?
It was mostly cells.
Oh, 8th grade?
In 8th grade?
It was.
Nah.
For-
it's not.
It was pretty much the.
I don't remember a single thing from 8th grade. I'm
I
gonna be
don't
honest.
either.
I was in the advanced.
In eighth
I didn't
grade,
even
Yeah,
go
I
to
was
school
also
here
in
in
the
the
advanced.
8th
We mainly
grade,
just
so-
talked the entire period.
I wasn't
never
in
studied it.
advanced.
Okay.
We mostly
Yeah,
talked.
you got a little bit.
It
We
was.
got stuff done, but like we finished in like 2 minutes and we just sat there the rest of the period talking.
I didn't go to
That's
school
productive.
here in
Okay.
8th grade.
So let's talk about how we got there. How the history of the atomic theory. We've already talked about a little bit about this because you did your presentations, correct?
Yeah.
Who was the first guy?
Democritus.
Democritus.
Didn't he like build off of another guy though? Or, like,
Democritus was the main guy.
yeah.
He said that everything was made up of small, you had a smallest particle.
In different shapes and sizes.
Also known as atoms.
Which means indivisible.
And he was also an
I
outcast.
didn't write.
Yeah, because Aristotle.
So,
You're wrong.
I was busy
You're
writing my
wrong.
essays.
Everyone knows
And I
it's
only
made
got
by
one
the Boundary Fire.
Yeah.
Jay asked me if we started this essay, so I'm not really, I just have to write one. I had 900 words on my first essay. If I don't get a high grade, and I checked it like 12 times. Get a high grade.
All right. So he thought all matter had its own smallest particle that was no longer indivisible. Okay. He used the word atomos to describe that particle, which means indivisible.
Yes.
And that's where we get the word for atom.
Correct.
What?
He was correct, but also incorrect.
Correct. All right. So
10 minutes.
So how many years later did we take this theory back up?
Like a lot.
2000,
Good, like,
something like that.
About a little over 2000.
2,500.
To be exact.
So
4 days.
4 days.
12 hours. 16 minutes.
7 dog
39,
days.
30, 40, 41. 42.
shut up. Okay. Who was it though? Who was the next guy?
Dalton.
Dalton.
That was a different guy.
My guy.
Oh, that was.
And his theory was similar to what Democritus said. There were everything was made up of small spheres called atoms. And the atoms were indivisible. And make sure you read that as indivisible, not invisible. That's different.
Well, I mean, they're not wrong though.
You can see
Because
them.
it's invisible to the naked eye.
Single ones are.
Yeah.
But you can see atoms. You're seeing atoms right now.
Well, yeah, but like still, like you can't like see the atom. You can see what it makes up. You can't like see the atom.
But what is this? What is seeing even?
It's one of the five senses.
All right. Who's after Dalton?
Some guy.
The
Right.
Bohr.
Student.
What?
I don't know how to say it.
Rutherford,
Bohr.
right?
Not Bohr.
Rutherford?
No, not Rutherford.
Heisenberg.
No. We're going the wrong direction. What's that?
Chadwick.
No.
Ruther.
Thompson.
Oh, I forgot about him.
Rutherford came after Thompson.
Making sure you knew that.
It was Justin.
Rutherford was his
It was
student,
J.J.
right?
Justin Jones Thompson.
Yes.
Justin
Ew.
Jones, the slap man.
What did he discover?
No, wait. Well, I say electrons, but I
It's electron.
Yeah, not.
Electrons.
Oh, god dang
Did we have such advanced technology to see electrons? Did he just base that off of a theory?
No. What he was actually seeing in the cathode rays was electrons.
That's gross. You know, I wouldn't mind living in like an old civilization where you just kind of like listen to what people tell you and live your life. I wouldn't be mad.
He had the plum pudding model.
it. That sounds good.
Did it look like plum pudding?
He thought the atoms were these spheres that had these
Please look at everybody.
charges, negative charges, corpuscles he called them, that we actually know to be electrons.
But he thought there was
The negative charge, they were scattered about in this fluid of possibly charged liquid, so to speak. Okay? That's what he thought atoms were.
Plasma.
Okay, that was the positive charge was like the pudding.
So protons were linked.
That's why I put it.
Yeah, he didn't, well, they didn't know what protons were.
You're just.
He had no idea. He just knew there was a positive charge to counteract the negative charge.
Were they so small that you couldn't see it? It was just a liquid.
Maybe. Alright, who's after Thompson? Rutherford.
Hey, it was right.
Isn't he a student or something?
Was he the what?
Wasn't he like Thompson's student?
Yes, he
or
was
something?
Thompson's student.
Yes.
Oh yeah, I knew that.
Ernest.
Ernst. What did he do?
Discover the nucleus.
Discover the nucleus.
Gold.
He discovered the Ford F-150.
Yeah.
He used the gold pole experiment. Who's next?
Bohr.
What?
Bohr, right?
Bohr.
Bohr.
Dang it, the one time I don't sing.
That's
He's dead.
boring.
Actually, no, Chadwick was next.
Oh. Okay.
Sorry. Well, they were pretty close to each other.
I'm not gonna get mad at you for mispronouncing their name. They're dead.
Exactly. Would you get to make a joke? I'm sorry.
Should be James Chadwick.
James Chadwick.
Good to know.
Make the name James to John and then take out
Yeah.
Chad.
There we go.
John Chadwick.
No, I said take out the Chad.
John Wick.
Yeah, John Wick discovered the nucleus.
John Wick
Name a kid
discovered.
Chad. You're a
Then he
fool.
shot it.
Yeah, he shot
He stole
that.
its dog.
It made him bleed.
Yeah, because it's always told his dog.
He made them
No, he
neutral.
stole the dog's protons.
Yeah.
John
He
Wick
just saw
made
the
them
blood
neutral.
come out of the air.
Next is Bohr.
So neutron's like Switzerland. What?
But you can actually convert a neutron to a you can convert a neutron to a proton.
But like still Switzerland. Because like
Because
you
it
could technically,
ejects an
you could
electron.
technically convert Switzerland too.
Niels Bohr. He proposed the planetary model for the atom.
I do remember doing the big planetary model of all the elements inside of 8th grade though.
Yeah.
Yeah, he proposed the electron
Oh, I
shells.
remember, yeah.
That's the one y'all studied
I
back in the
remember
day.
coloring one.
It's where you had
Yes,
the nucleus, then you had these rings.
And those rings, there's only 2 on the first ring, and then there's like 8 on the next
Yeah.
ring or something like that.
Yeah, which is all incorrect, but it's okay.
So when did the cloud thing become like super big?
In like the 30s.
Well then why are we still teaching that?
Because it's easier for a
Oh, okay.
junior high kid to conceptualize.
Gotcha.
Yeah, because you would totally like tune out the quantum model.
I-
It's still, a lot of things about the quantum model are still above your head.
I have a feeling you.
Some of it above my head.
I have a feeling you memorized the entire periodic table.
You probably had
Yeah,
to.
so do the pre-AP kids.
No, they don't.
I thought they took a test over it.
Not the whole thing, just a few elements.
I couldn't do that.
Okay.
I could not memorize the whole thing. I can't even memorize my Spanish.
I mean, Memorizing is not exactly correct. I know all the elements and their symbols. You count that as memorizing. I know a lot of their atomic numbers. After Bohr was the quantum model.
Quantum model.
Okay. And it has to do with the electron cloud, which we'll get into a whole unit about electrons later. And it was proposed by a lot of people, including Einstein,
Einstein's
Heisenberg,
Heisenberg's friend.
Schrodinger.
They use the quantum. Aren't these also the people that made bombs in World War II?
Yeah.
Oh, sure. I remember that dude. Yeah, he was a dude.
Millikan.
Schrodinger?
That
Probably.
sounds
Oh,
like a name
Kroll.
from
I remember that dude. That guy is a cat.
Are you basically just laying off the people that were on the
Manhattan Project.
Yeah, Manhattan Project?
A lot of them were.
Like Einstein.
Why do you think they got them to work on the Manhattan Project? They were smart guys around.
And they knew atomic stuff.
Yes.
And we wanted to make an
Okay.
atomic bomb. That kind of makes sense.
So that's the quantum model. Like I said, we will have a whole unit just on electrons and how that affects the quantum model electron. That's actually the next one. Any questions about that? Okay. Two more kind of vocabulary terms that you need to know. We'll cover this later too, but it's kind of important now. Atomic mass, or excuse me, atomic number, atomic mass. Should have did this a while ago, but I forgot. Atomic number. What's atomic number? You may know.
It isn't it the number that tells you where
How many electrons it has?
like where it is on the element table?
It is where it is on the periodic table, but what does it like correspond to?
It's mass.
How many protons?
How many protons it has?
Interesting here.
What's my atomic number?
A lot.
420.
It's really.
And the atomic number defines the atom. So all atoms that have 6 protons are carbon. All that have 7 are nitrogen. 8 are oxygen. 92 are uranium. So it defines what it is. Okay, by the number of protons. And that's the atomic number. And the periodic table is in order by atomic number. Next is atomic mass.
Isn't that where you add up all of the protons and electrons and all that together? And you
Why would electrons matter? They don't weigh anything.
Neutrons and
Number of protons and neutrons.
Well, I mean, technically they do.
They do weigh something. You told
Not
us.
as far
this.
as we're concerned, they don't.
Yes, they do. But like,
it doesn't even have one.
It's the number of protons plus the number of neutrons. So, for example, in uranium, the atomic number is 92, but the atomic mass is 238. For the most common one, anyway.
So 360.
So, if the mass is 238 and the atomic number is 92, how many neutrons does it have?
360. No.
146. So that's how you figure out how many neutrons there are in that particular isotope of uranium. Uranium, like all elements, can have multiple masses, depending on what isotope it is. We'll talk about isotopes later when we get to the periodic table. Any questions about that? All right.